Welcome to Lesson 7.3, Day 2. We are looking at writing the equations for a hyperbola given certain characteristics, as well as looking at calculating the eccentricity. Those are our learning targets for this video clip. Write the equation for the hyperbola with the given characteristics. The things that we need to write the equation of a hyperbola is the value of a, the value of b, and the center, so that we can complete our equation. In this case, we're given the vertices and the foci. The vertices will help us find the value of A and the center. The foci can help us find the center and the value of C. We're going to have to use the relationship between C squared, A squared, and B squared to find the value of B squared. And that is C squared equals A squared plus B squared. To find my center, I can use the midpoint formula. Negative 3 plus negative 3 is negative 6 divided by 2. And then I have negative 6 plus 2, which is negative 4, divided by 2. This will give us negative 3, negative 2 for our center. The variance from this to this, notice it is the y-coordinate that's changing from the vertices and the center. It's changing by 4 units on either point. So the value of A is matching up, it's going to be under the y, and it is changing by 4 units. This means that A squared is 16. So I have y minus negative 2, which is plus 2, quantity squared, over 16, minus x minus negative 3, which is plus 3, quantity squared, over b squared once we get it, equals 1. The value of c can be found by looking again at the change of the y-coordinate. From negative 7 to negative 2 is a change of 5 units. This means that c squared is 5 squared, or 25. Since 25 equals 16 plus b squared, if I do 25 minus 16, I get 9 for the value of b squared, which I will put under x. Now we have our equation for that hyperbola. Next we look at an example where we're actually given 2 asymptotes, and really the only part I'm most concerned about with the asymptotes is the slope. The y-intercepts can be negligible depending. Not if I'm looking to graph them or find them, but for this. For this equation, again, we need a, b in the center. The good news is we have the vertices, so we can easily find the center. We're going to do the midpoint formula. Negative 3 plus negative 9 is negative 12 over 2. 0 plus 0 is 0 over 2. So our center is negative 6, 0. It is the x-coordinate that is changing as I look at the vertices and the center. So I know that A will change and it'll be under the value of x. That means the x term will come first. And the previous one, A changed with y, so the y came first. To go from negative 3 to negative 6, it's a difference of 3 units. Also from negative 6 to negative 9, a difference of 3 units. So A squared is 9. That's important to know because now when I look at these equations to help me find the value of b. Well, first off, let's start with our equation. We have x minus negative 6, which is plus 6 squared, over a squared is 9. Minus y minus 0 is just y squared, over b squared equals 1. We have to find the value of b squared. So I'm going to take this slope, which is a slope of plus or minus 2, and that's 2 over 1. It is equivalent to 3. Nope, 3 was the x. 3 was under the x. So remember, for rise over run, it's y over x. So I don't know what b squared. B is under y. So this is b over a. A is 3. When I cross multiply, I get 1b equals 6. So that means that b squared is 36. Using the slope of the line, always doing the value under y over the value under x, the square root of those. So I don't know what b is, but I know it goes over 3 because 3 is under the x. The 3 squared is under the x. All right, now also for hyperbolas, we have the transverse, which is like the major axis, the conjugate, which is like the minor axis, although it might actually be longer. The conjugate axis is the distance between the co-vertices. It's 2 times that. This means that since 2b equals 10, the value of b has to be 5. I also gave the vertices, so I can quickly do the midpoint formula. 3 plus 3 is 6, over 2 is 3, 2 plus 6 is 8, over 2 is 4. So there's my center. Since it is the y coordinate that changes for the vertices, the y will come first. The value of a will go under the y coordinate. Difference from 6 to 4 is 2, from 4 to 2 is 2, which means that a squared is 4. So as of right now, we have an equation of y minus 4 quantity squared over 4 minus x minus 3 quantity squared over b squared equals 1. Well, since we knew the conjugate axis length was 10, the value of b is 5, b squared is 25. So here is the equation for the hyperbola for this example. One last example. This time I give you neither the vertices or the covertices, but I do give you the foci and the asymptotes. Assuming that this fraction hasn't been reduced, we'll easily be able to get our values of a and b, and we can figure out how that fits into c squared equals a squared plus b squared. So the foci, because I have two of them, can help me find the center. 2 plus 12 is 14, divided by 2 is 7. Negative 2 plus negative 2 is negative 4, divided by 2 is negative 2. Our center is 7, negative 2. Our foci and our vertices are always on the same axis. For ellipses, they're on the major axis. For hyperbolas, they are on the transverse axis. So I know that since it's the x coordinate that's changing for the foci, the x coordinate will also change for the vertices. So I know that c, 7 minus 2 is 5, 12 minus 7 is 5, and that's under the x variable. So that's the value of c. If it's x that changes for the foci, it'll be x that changes for the vertices as well. So I know that it's going to start with x. So I have x minus 7 quantity squared. I don't know what a squared is yet. And I have y minus negative 2, which becomes plus 2 quantity squared. I don't know what b squared is yet. I do have this ratio though. Here's the cool thing. I know c is 5. So c squared is 25. Now I'm going to see if this is or if this was reduced. If this was reduced, then I can try to find the multiplier to make this equation work. C squared equals a squared plus b squared. Right now though, remember the top number is the one that's under y. Well, under y is going to be b since y is second. And under x is going to be a since x is first in this equation, just like the foci, it was the x that changed. So that means that I'm going to try this. A squared would be 16, b squared would be 9. 16 plus 9 does add to 25, so this wasn't reduced. It actually was 3/4. This means that a squared is 16 under the x, b squared is 9 under the y, and we have our equation. All right, last concept is eccentricity. The good news with eccentricity is it is calculated the exact same way as it is calculated for ellipses. E equals c over a. E equals c over a. The difference is that for a hyperbola, c squared equals a squared plus b squared, and for an ellipse, c squared equals a squared minus b squared. So what's nice is, since these ones, at least since I gave you the equation, the value of a is always the first number. So square root of 64, the value of a is 8. The value of b, well, to find the value of c, I need to do a squared plus b squared to get c squared. 64 and 80 gives us 144, a nice perfect square. That means the value of c is 12. So if I'm finding the eccentricity, I need to do 12 over 8, because I'm doing c over a, or c over a, yep. In this case, it's 1.5. For an ellipse, the eccentricity should always be between 0 and 1. For a hyperbola, it doesn't have to be. It can be between 0 and 1. It can also be more than 1. The value for letter example B. This case, a squared is 48. The square root of 48 is divisible by 16. by 16, which is square root of 16 is 4, so this is 4 square roots of 3. To find the value of c squared, we need to add a squared plus b squared. 48 plus 36 is 84. 84 is not a perfect square, and 16 does not go into it, but 4 does, giving us 2 square roots of 21 for the value of c. So we will do 2 square roots of 21 over 4 square roots of 3. As an exact value, the 2/4 becomes 1/2. The 21 over 3, both under the radical, becomes the square root of 7. So this would be square root of 7 over 2 as an exact value. For a decimal approximation, we could simply do the square root of 84 over the square root of 16, or not 16, of 48, which would give us roughly 1.3229, or I could do the square root of 7 divided by 2, also giving me that approximate value of 1.3229. If it says to round to the nearest hundredth, we'd round to 1.32, nearest tenth 1.3. This concludes the video notes for 7.3, day 2. At a later date, we will discuss the discriminant and once again solving for intersection points with a line and a hyperbola. This concludes the video notes. Finding eccentricity and the other learning target, writing the equation of the hyperbola given certain characteristics. Have a great day.